Hi there, Chargers. Mrs. Boyd here. We're going to start a new chapter, chapter 10, about square root functions. A square root function, just so we know, is any function that has a radical in it. And the radical will have to do with our x. Our x term for these square root functions will always be under the radical. The parent function you can see below right here, y equals the square root of x. We're going to do the square root of the x value to find the y. Like this says, it's a type of radical function. Radical is another name for the square root. All right, the expression under the radical sign is called the radicand. So the square root is the radical underneath the square root. So x in this case is the radicand. In function notation, we can write this as f of x equals the square root of x. And we're going to look at the picture to try and determine our domain and range. The domain, remember, is anything that x can be. So if you look at left to right at how this looks, the farthest left our graph will go is x is 0. And then right, it's got an arrow up here telling you that it goes on forever and ever and ever. So I can extrapolate from that the domain will be x is greater than or equal to 0. 0 is the lowest point that x will be, and everything other than that is greater. The range is everything that y can be. So now we're going to look at our graph in a horizontal or a vertical kind of way. X is horizontal. Now we're going to look vertical. So if we start at 0 with y, and then we go up, and it's just going to keep going up and up and up and up forever and ever. So the lowest y will ever be is 0. So I can say that my range is going to be y is greater than or equal to 0. X is only going to be 0 or more. Y will only be 0 or more. You'll notice that when we graph it, if you can compare that to a parabola is a standing up U, and the square root function is a U cut in half on its side. So they kind of resemble each other, but in a weird, abstract-y kind of way. So let's get to doing our own stuff with these radical functions. We're going to graph f of x equals 2 times the square root of x, and then find the domain and range. We're always going to make a table of values for these. So our first value, I'm going to go ahead and make the table. Our first value, we're going to take what's the radicand, which is x, and I'm going to set that equal to 0. If there were anything in the radicand besides just x, I would solve and get x alone, but there isn't. X is just 0. So x equals 0 is going to be our very first value of x in the table. So the square root of 0 is 0, and 0 times 2 is also 0. So it's going to be the first point on our graph is 0, 0. Now, to do this, we need to know the first 3 at least perfect squares. So I'm going to write them over here. Well, 0, first one. Perfect square is 1, because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So those are our first 4 perfect squares. So I want you to graph at least, or find the values for at least these first 3, probably even the first 4, just to make sure we're doing it correctly. So next one we plug in will be 1. So we've got the square root of 1 is 1. 1 times 2 is 2. So that's our next point. X is 1, y is 2. 4 will be next. So we'll have 2 times the square root of 4. The square root of 4 is 2, and we have 2 times 2, which is 4. So 2, 4 is going to be, oh, I wrote that completely backwards. I'm so sorry. It will be 4, 2. Sorry about that. So x is 4, y is 2. Gosh, I wrote it wrong again. Holy crap. I plugged in 4 here for X. I got 4 for Y. Third time's a charm. It's 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Let's plug in 9 just to be safe. Since I can't be trusted, obviously, we're going to plug in 9 for X. So we have 2 times the square root of 9. The square root of 9 is 3. And 2 times 3 is 6. So when X is 9, 1, 2, 3, 4, 5, 6, 7, 8. It'll be a little off paper, off the graph, I mean. Then Y is 6. 1, 2, 3, 4, 5, 6. Now we can graph this. Kind of our U. Mine's not very smooth. Our U cut in half and laid on its side. Holy moly. Now we're going to look at the domain and the range. To find the domain and range, we're going to look at the first 2 values in our table. The first value for X is 0. So for domain and range, they have to do with X and Y. So I'm going to write X, Y. I'm going to leave some blank space, and then I'm going to write next to X and Y the first 2 values in my table, 0 and 0. I look in the X column. I now look at 1. Is 1 greater than 0 or less than 0? It's greater than 0. So that means my sign will be greater than or equal to. I look in the Y column. The next number down is 2. Is 2 greater than 0 or less than 0? It's greater than. So Y is greater than or equal to 0. Okay, so whatever the signs are as you move down the table, if your numbers get bigger and bigger, then you greater and greater. If they're smaller and smaller, then it's less than for your signs. So you try this one. Pause the video. Same idea. It's going to look really similar. Ready, set, go. All right, so we're going to solve this baby, or we're going to graph it, I guess. Oh, let me scoot back up here. Okay, no. All right, we're going to graph y equals -3 times the square root of x. Remember, first, I'm going to set whatever the radicand is equal to 0. So in my table, my first value is going to be 0. Plug in 0, and I have -3 times the square root of 0. The square root of 0 is 0, and 0 times -3 is 0. So when x is 0, y is 0. Now I set my x equal to the next perfect square, which is 1, and that's the next number on my table. Plug in 1 for x, I get -3 times the square root of 1. That's -3 times 1, which is -3. So when x is 1, y is -3. Next value, I set x equal to the next perfect square, which is 4. That's -3 times the square root of 4. So the square root of 4 is 2. So that's -3 times 2, which is -6. So when x is 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. All right, let's graph what we've got. Let's smooth line it out there. And that's what our graph should look like. A little bit more of a exaggerated, a less steep curve, right? It's longer than it is smaller. If our original graph, our parent graph, is y equals the square root of x like it was above, then that one is 0, 0, 1, 1, and 4, 2, always. Then you can see how it's different. The blue line is has a vertical stretch to it compared to the red one. We want to state the domain and range. The domain, we remember we are x and y. We look at the first 2 numbers in our table. So 0 and 0. Then we look at the next number down. for x? Is 0 greater than 1 or less than 1? The numbers get bigger, so our sign is going to be greater than. For y, do the numbers go bigger or smaller? They get smaller, so that is going to be less than or equal to 0. Getting it good? I hope so. Let's move on to the next one. So just a smidge different. Now our graph is g of x equals the square root of x plus 1. The radicand is what's under the radical, and that's just x. And we set that equal to 0 to get the first value on our table. Now we plug it into the equation. The square root of 0 plus 1, square root of 0 is 0, and 0 plus 1 is just 1. So when x is 0, y is 1. Next perfect square, we set x equal to 1, and that's the next value in our table. Take the square root of 1 plus 1 equals, square root of 1 is 1, and 1 plus 1 is 2. So when x is 1, y is 2. Next perfect square, x equals 4. We put the square root of 4 plus 1. Well, the square root of 4 is 2, and 2 plus 1 is 3. So when x is 4, y is 3. We can connect these with our line. Next, it says compare it to the parent graph. Well, the parent graph is always 0, 0, 1, 1, 4, 2. I'll put that in the wrong spot. And then we connect the lines, or the dots. So, how do you think the blue line is different than the red one? I hope you answered that it moved up 1. So this plus 1 made our graph move up 1 from the parent. Next, let's do the domain and range. You know, domain always is x, range is always y. The first values in our table go to the right of x and y. If I go to 0, from 0 to 1, the numbers get bigger. So that's greater than or equal to. And from 1 to 2, the numbers also get bigger. So that's greater than or equal to 1. Super. Let's keep going. This one, same idea, except for now the radicand is not just x. Now it's x minus 2. So we're going to set x minus 2 equal to 0. And then we add 2 to each side to get x equals 2. When I make my table, the first value now instead of 0 is going to be 2. So I plug 2 into here, and I get the square root of 2 minus 2. That's the square root of 0, which is just 0. So when x is 2, y is 0. Now, instead of the next perfect square being 1, we set x minus 2 equal to 1, and then solve for x. That means x is 3. We plug 3 in here, get 3 minus 2. That's the square root of 1, which is 1. So when x is 3, y is 1. Last but not least, we set the radicand equal to the next perfect square, which is 4, and then solve for x. X is 6. So when x is 4, or excuse me, the next number that we're going to put in is not 4. It is 6. When x is 6, we have the square root of 6 minus 2. That is the square root of 4, which is 2. So when x is 6, 1, 2, 3, 4, 5, 6, y is 2. Connect those with the line, and that's our graph, that's our function. We want to compare it to the parent graph. So that's 0, 0, 1, 1, 1, 2, 3, 4, 2. You can see by looking at the end point along the x-axis that the -2 in the radicand has moved our graph right 2 places. So we started at red and we went 1, 2 to the right. We need the domain and range. The domain, we have x and y. We use, again, the first 2 values in our table. So 2 and 0. We go from 2 to 3. Those numbers get bigger, so it's greater than. And from 0 to 1, those also get bigger, so it's greater than. Example 5 is like what we did above, so I want you to try that one on your own and then come back here. All right, again, our radicand is just x now, so we're going to say x is equal to 0 as our first value in our table. I'll put 0 there. We plug it in. -2 times the square root of 0 plus 1. Well, first we do the square root, so that's -2 times 0 plus 1. -2 times 0 is 0 plus 1, and 0 plus 1 is 1. So when x is 0, y is 1 is our first spot. Then we set x equal to the next perfect square, or 1. So -2 times the square root of 1 plus 1. Square root of 1 is 1. So -2 times 1 plus 1. -2 times 1 is just -2. And -2 plus 1 is -1. Oh, cat just jumped on the desk. So when x is 1, y is -1. Last, we set x equal to our next perfect square, which is 4. Got -2 times the square root of 4 plus 1. Square root of 4 is 2. So 2 times 2 plus 1. -2 times 2 is -4 plus 1. -4 plus 1 is -3. So when x is 4, y is -3. Connect our dots together. And we see that now our graph is flipped upside down and moved up 1, and it's a little stretched out too. So we need to do the domain and range. Even though it doesn't say it, it can't hurt. X and Y for domain and range. First 2 values in our table. The domain, we got 0 and 1. Kitty. Ah! Gosh. We have 0 and 1. We move down the table from 0 to 1, gets bigger, so it's greater than or equal to. From 1 to -1 is smaller, so less than or equal to. Let's see. We're not going to do that last one. I hope you have a good grasp on what we're doing with these. The keys are set your radicand equal to the first at least 3 perfect squares, then solve for x if you need to, and then plug those values in carefully, write down all your steps, and graph what you have. You can totally do it. Follow up with these directions, and you'll be perfect. Let me know if you need any help. Good luck.